All right, you people, everyone following along, that would be Jose for today. So he actually does watch the videos. Good job, Jose. All right, anyway, okay, so I'm going to use this right here to solve my problem again that we just did using log. So I'm going to take this right here because I already took the integration here. So I'm just doing a little bit of algebra from this point right here because we already did the integration on top. But right here, I'm going to actually get this piece right here. So when he did this yesterday, I came up with this, right? Okay, this is just using regular log. Now, okay, going back to this, I know that it's going to be triple again, right? My A value. So my A value is 3A, right? So I have 3A. My A sub naught, right? Yeah, my A sub naught is just my A, right? Because it's 3 times the original. Yeah? And, let's see, doubles of 5 hours, how long will it take? So I have 2 points here. So I have 2 points. So starting out, I have 0, comma, A. And then in 5 hours, it's going to be 3A. Okay? Yes, no, maybe? So whatever it comes out to, I know I'm going to use my A equals A sub naught e to the kt. So I have a couple, I have like 2 variables here that I don't know here. I don't know the k, and I don't know the t. Okay, so I know that it is, so wait, crap, wrong one. Number of bacteria doubles in 5 hours. Oh, I'm sorry, doubles in 5 hours. Come on, work. Work. Doubles in 5 hours. So 2A, there we go. All right. So if it doubles in 5 hours, I should have 2A. So let's go through and use these. So my first initial is going to be just A, and that's going to be e to the k. Now, I know the time for this next thing, so that's going to be a 5, and that's going to be equal to a 2A. So this is all just algebra. So I'm trying to solve for k now, right? Because k is going to be the rate that I'm using. So divide both sides by a. So I should get 2 equals e to the 5k. And both sides here. She has saved your life. All right, ln both sides. So I'm going to end up having ln of 2 is equal to 5k. And then divide by 5. So k is equal to ln 2 over 5. So I'm hoping someone is not napping, they're actually writing it down. All right, so I'm going to erase this part here. So now I have the k value. Okay, how long will it take for it to triple now? That's my end result that I'm looking for. So I'm going to go 3a equals my initial, which is a, e to the, I'm going to look for t, right? So ln of 2 over 5 times t. So we're going to get some weird decimal of the ln2 over 5. So we'll eventually get to that one. All right, so divide both sides by a. So I'm going to get 3 is equal to e to the ln2 over 5 times t. And then I'm going to ln both sides. So ln of 3 is equal to, okay, whatever this is, which is going to give me some decimal. What decimal is that going to give me? I kind of need that one. ln2 over 5, what do we get? Anyone?
0.138.
0.138. I need one more number.
6.
6. All right, and that's going to be a t there, right? So remember, in calculus, when I'm approximating, I always need 4 decimals.
I thought it was 3.
Huh?
I thought it was 3.
Is it 3 or 4?
What?
Is it 3?
I was
Have I been saying 3 all year?
Yeah.
Okay. I'm sorry, I fell and hit my head earlier. So, all right, so now from here, what am I going to do to try and get t? Divide. Go ahead, divide. You're not processing, you're snoring. You're making like grunting noises. Bruh, seriously. Okay, use the read write strip, you won't snore as much. Alright, what do we get for t? Because I'm hoping some people are trying to put it in the calculator, not stare at me awkwardly. Yes, that's an awkward stare. What? Calculator, calculator. There's one calculator over there, there's one there. Okay. A lot of people know calculators. Frank, no calculator.
Oh wait, we already know it, right?
Huh?
Don't we already have the answer
No.
from yesterday?
No, because they're solving it in different ways. Solving different ways, so they're going to be different in your approximation.
Why don't we just give them the exact answer? ln over ln 2 over 5.
Yeah.
But
Like there's a
I
6,
will
right?
so like the last 3.
So you're saying that it would be 5 times ln of 3 over ln of 2 is equal to t. But then if it's in that form, it's actually, I can,
Would it be
What was that?
will it be the same? Wait, hold on. It should, right? 'Cause then-
I don't know, you got a calculator. Some people don't have a calculator still. Even there, I'm like staring at them.
if they have a calculator, I know.
My calculator's not even turned on.
Did you try talking to it nicely?
Yeah. I said, pick up the phone. Wait, what did you do?
No, seriously, that's not even. Man, you're gonna get left on red like that.
Yeah.
7.92481.
C. I got 7.9.
Yeah,
7.926.
Oh, that's for the other one. You know, I was really close.
No, what did
Other
you
times
do,
I'm
though?
really off.
What did you do, though?
I put it in like this. Watch.
7.1?
There's
Someone said
two
7.7.
answers. Yeah, there's 2 answers.
Is it the same?
was off by
A little bit.
0.0021.
Mm-hmm.
But is that close enough?
Yeah.
Let's try plug it in.
Oh, okay.
Because if you plug in like that, you're rounding it.
Yeah, you rerounded here, and that's why. So if you do here, fine, just show your work. If you're showing your work, especially on the AP exam, if you are showing your work that you rounded at this point here, then you're using, your answer should be the rounded answer. But if you went all the way to there for the other one, to here, yeah. Does that make sense? I'm hoping.
So she's more right than me.
Yes.
By 0.002.
In math, that's a lot.
Is it?
Mm-hmm.
This looks.
If you're sending a mail,
I know, right? Seriously, it's super important, especially when you're, shooting things from your Death Star at, you can't be off by that much. I know, right?
from the Death Star?
Yeah.
You have a whole plan to say that.
Okay. Okay, so now, let's pretend that the Earth is the Death Star. And we're gonna blow up Mars.
Yeah.
Are we
Have you
moving?
seen Mars?
It's pretty far.
Have you seen how big it is?
I mean,
This big.
it's like,
All the-
Oh,
It's
it's
big.
like.
Oh,
more
okay,
than
so
big
you
as
have a
the
huge
road.
planet that you're shooting at, right?
it's smaller
So-
than the Earth, though.
Huh?
It's smaller than the Earth.
Could we
But-
aim at
but-
Jupiter?
Okay. So, let's aim at Jupiter. Can you see Jupiter in the night sky?
Yes.
How big is it?
It's
Small.
bigger
Yeah,
than this
okay,
room.
so now, so you have to be super accurate, okay, when you're aiming your Death Star. So you cannot be off by,
0.002.
can't be off by 0.002. See, you'll miss it altogether. See, you'll end up just hitting Endor, okay, and all the Ewoks, okay. So seriously, like don't kill the Ewoks. Anyway.
But also maybe kill the
All right, here's another one. Skull of an animal of an Ewok found in an archaeological dig after they found the planet of Endor. Contains about 20% of the original amount of carbon-14 left. If the half-life of carbon-14 is 5,730 years, how long ago did the animal die?
A couple years ago.
More
than one.
Say 20%, right?
It has 20%.
What?
Left, yes.
20% left.
Like 80%. And then so half.
20% of the original amount.
So 50% was
So
500.
it's like,
5,000.
yeah. So like 50% is that one, right? And then in another half-life, it's gonna be 25%, right? And it's gonna be like
Then we just take
half of that.
30% off of that.
30.
Yeah, because you need
Oh
20.
wait, true. Okay. But 30 isn't half. 25 is just easier. Like,
So it's what off equals first 5,000.
Okay, so it doesn't say the amount, right? Okay, so there is a percent on this.
0.5.
Okay, so I know that at this point right here there is how much?
50.
There's 50%, right? And I know at some time t, I am going to have 20%. But now at time 0, I have
100%.
Wait. Oh, wait.
Yeah? Okay, let's go ahead and do a little equation out of this. So I know that I should start off with 100 e to the k. What do you think my t should be?
Zero.
No, not 0. Because that gives me my initial, right?
Oh, so 50%.
Oh, okay, yeah, I want the 50% one, right?
So 500.
There we go. So we got 5,200.
730.
No, 5, 7. Okay, and that has to equal. What does it equal? 50, right? So whatever is left. Okay, so let's go ahead and do the math on this now. So divide by 100, I get 1/2 equals e to the 5730k ln both sides. So if I ln both sides, it's going to be ln of 1 minus ln of 2 equals 5,730k. I use the ln rule right there because if I have a fraction inside of ln, it's the top minus the bottom. If it's a multiplication, it would be a plus sign there. Okay? All right, so, and that's going to be super helpful because ln1, what's ln1? 0. ln1 is 0. So whenever I could actually get rid of part of my stuff, you know, it's going to be helpful. All right, so then divide both sides by. So I know that piece was 0. So I should have a negative value, right? So if I have a negative fraction, that means that it is going to be a decay. Very good. Decay. If it's negative, it's going down, it's a decay.
It's half-life, so we know that.
Yep, it is going down. All right, so there we go. Now, we got to try and figure out that 20% now, right? So we're trying to solve for t again, aren't we? Okay, so from solve for t again, I know that I'm going to have 20% is equal to my initial of 100%, e to the negative ln of 2 over 5,730 times t. Jess. And divide by 100, so 20 over 100 is 1 over 5, right? So I should have ln of 1 minus ln of 5 over, what's that going to give me?
Negative 0.00.
Ah, not yet, not yet. Equals, okay, yeah, let's do that part one. So negative ln, I'm skipping some steps here, so I don't know if you guys notice that. All right?
So you just divide that by ln.
Mm-hmm. So that means that t should give me my negative ln of 5 over ln of 2 times 5,730. And there should be a negative there also.
Wait, so when you divide by negative, it should, yeah.
Hmm?
So it would be a positive number, actually.
Yeah, because I did this right here. ln1 is still 0, so I had a negative ln5, right? And I'm dividing by a negative ln2, right? So the two negatives should make that one a positive.
13,304.
So am I close to being right? Am I close to being right? Did you already get it? You got 12,000. Odin said it's 13,000.
How many decimals did you get? Odie, how many decimals?
13,300.
One.
Yeah, 13,400.
Point
4.6.
Okay. 13,000.
304.
That's how long ago it died. Okay, because all life is slightly radioactive, carbon-14 is one of those things that if it is still alive, it is still replenishing that carbon-14, but once it dies, it stops replenishing the carbon-14. And that's why we're able to carbon date items to see how long ago that it passed away.
How do we know the half-life of carbon-14?
It's been tested, and we use that one because it is one of those things that is I don't know, some type of, it's a constant. So it's a constant. Certain things that you could always count on. Okay, like, let's see, the wavelength of a certain, I can't even remember whatever element. It actually, it puts off a wavelength, and something like 1 trillion revolutions of this will give you exactly one yard or 1 meter or something like that. So it's because certain things, like if you think about who made the first ruler, okay, 12 inches, right? That's kind of weird, right? 12 inches, now who's to say how big an inch actually was? What is it to be accurate at that measurement? No, seriously.
I guess. Well, I mean.
Okay, how do we know, even better, how do we know that today is actually Thursday?
We just accept it.
We're assuming that since the beginning of counting, that someone actually kept count, that today is still supposed to be Thursday.
It's probably not.
What if someone lost count back in the day, and today is not Thursday, they lost count and say today is Friday? But huh?
But like, who cares? Because if
Exactly.
everyone says it's Thursday, if everyone says
Exactly.
it's Thursday, then it's Thursday.
Okay, exactly. Okay, someone kept count.
No, but like, if everyone today in the world said it was Saturday, then it's Saturday.
Mm-hmm. Okay, it's one of those constant things that we have to just use, right? Okay, so carbon-14 is one of those things. Okay, so even better, chemistry.
We're doing that.
What is a mole?
A unit of measurement.
Okay, it is a unit of measurement, and so it's a standardized unit of measurement that is exactly how much?
1 mole.
6.02 times 10 to the 23rd.
E to the 10
Yeah.
10 to the 20.
Okay, so yes,
Oh.
that is a unit of measurement, right? That we have to assume, okay? Just like the first person that decided, hey, this is a cup, this is 8 ounces. What randomness did that come from in the first place? We're like, hey, look, I got this cup. We're just now all going to use this and say, hey, that is a cup. That's the measurement of a cup. Okay, at some point that they had to standardize that of what a cup was.
Wait, didn't they have to know what 1 ounce was before the cup?
No.
Because you need 8 ounces in a cup, or do they just?
Okay,
select
so
it?
now how many teaspoons are in a cup?
16?
No. Just so you know,
36?
okay, they're different units of measurement.
Mhm.
Kind of like where you have the metric system and you have the imperial system. You know, it's funny because in America, we're imperial, but we're not, imperialist.
No, but why does
Anymore.
it exist?
Why does what?
Wait, which one came
The
first
imperial
though?
system exists. Like,
Okay, so it is one of those things.
The metric system better.
Yeah. So it's kind of like, Nikola Tesla versus Thomas Edison.
Thomas Edison.
At the same time, they were pushing for America to either go DC or AC. So we could have been a country that actually was founded on DC, direct current, versus alternating current. It's a different thing.
Wait, what? What's direct current? What's alternating current?
One has wires in the ground, the other one is.
You forget nice words.
That's how I learned it.
Really?
Yeah, from this is American of
This
Us.
is America.
The story
Guns
of
in
us.
my ear.
Story of
of
it.
Us.
Okay,
You
okay.
make holes
Now,
in the ground.
yeah. Good try. Okay, direct current is direct current. So there is a direct line to it. AC is an alternating current. When you actually see it on a oscilloscope, there's a wave. There is an amplitude to it. There is a period for the wavelength. Okay, alternating current is a positive and negative together, where direct current is either a positive or a negative. So you're getting one or the other. Okay, so and producing DC is easier than producing AC, but transmitting AC is easier than transmitting DC, because DC you need a bigger cable, and it doesn't transfer through the ground or through anything very well, so it actually loses too much. Does that make sense?
Yes.
Or no? Maybe? So, anyway, we standardized the unit of carbon-14 because we've been able to model it over time, over 100 years, that we've been able to see that there is a specific decay rate of carbon-14. We use that as a standard unit of measurement. So, I don't even know. I know it's a meter, but there is some certain wavelength that actually is. There's so many wavelengths that will actually be exactly a meter. Or like there is a golden rule that actually has, the standard ruler that all rulers are set by. Okay, all right.
You think I think they would make a ruler before they discover that, though, right?
I mean, I don't think they thought it was a ruler, just like